Hold on, I'm clicking too many buttons. Let me start the countdown. All right, here we go. Hello, everyone. Yay.
Hey,
Hello, everyone in chat too. Good morning, good evening, afternoon, or good night, wherever time zone you're tuning into. This is the .NET Community Stand-Up Tooling Edition. So we're really happy to have our guest here, Stephen Toub. He is kind of famous for his performance blog posts, I think. So I titled this episode Sneak Peek of .NET Performance because you can only get it here. It's not like you can follow all of our open source work because it's all just out there. This is an exclusive, right, Stephen?
That's right, yeah.
That interview kind of contract? Okay, excellent.
Kendra's got some new level of authority here to sneak that on into like the highest level requirements. Like, yeah, I like it.
I can title these episodes whatever I want. Cool. So I feel like we should do a small what's been going on? The .NET 20th anniversary has been going on. That was on Monday. 20 years of innovation in .NET. Very exciting. You can find that live stream on this YouTube channel. I'm sure it's out there, but you have to watch this stream first, and then you can go and watch that recording. It's actually super cute. We have a bunch of videos from just people over the years, some nostalgia, a lot of the team talking about like what's new and what's coming. So the whole stream was like a mashup of really fun stories and swag and sharing just a little bit of what pranks we've had inside the team. Not too much, not too many.
I have still got to check that out. I haven't had a chance to keep up this week, but I remember, as I hijack, to speak for a second, I remember when I first worked with .NET outside of Microsoft, a little technology, I think for a while it was called ASP Plus, when it was the betas of .NET 1.0 and then ASP.NET, the initial ideas. And yeah, and I feel really old that was 20 years ago. I was playing with that stuff.
That's amazing. I didn't know that. Wow. 20 years.
Yeah.
I was not doing this 20 years ago. Well, we'll leave it at that. But I had so much fun collecting the videos and hearing about all of the hijinks that people pulled on the team. It was actually really, really, really fun. I wish we had a whole like prank segment because we really could have filled really like the whole hour with just some fun stuff. We didn't even mention. Anyway. Cool. So, Stephen, .NET performance, my number one question. We've had your blog posts over the years, every major release of .NET Core, and now just .NET, and because now it's just .NET. .NET 7 performance blog posts. Are we working on it? Is it in draft mode?
I mean, there will be one eventually. And sorry, my voice, I've had a cold and laryngitis, and so hopefully my voice doesn't entirely give out. But yeah, I mean, I usually work on them around July or August. So that would be my plan again this year. The other thing I end up doing, other than contributing improvements, is every time I see one come around, I sort of log the URL for myself to look at later. And so I've got my ever-growing list to go back and review. So I don't have to, in July, actually look at 6,000 PRs. I only have to look at, the 500 that I already filtered for myself.
Right, only 500 PRs. So I was going to say that .NET 6 was 400 PRs that you summarized in that post.
Yeah, that was
literally. It's not hyperbole. Yeah.
So people were pointing out after the fact that if you asked, for a print to PDF, it came out at like 120 something pages. So hopefully no one was actually printing it, and I was responsible for the death of a lot of trees. But yeah, I mean, there's a lot of improvements that went in, and has been in every release. Part of the length is I just like talking about it. So, and I like providing background and details, and so I can be a little long-winded. But it's also, there's just something like 600 actual, PRs in one way, shape, or form contributing performance improvements. Some small, really tiny, eliminating one little allocation over here, making one little code path over there faster, and some of them kind of really overhauling how a particular piece of functionality worked. And it's some really exciting stuff. And some of it as well was sort of previewed in .NET 6 and will come to fruition in .NET 7, or was previewed in early releases and sort of finally landed in .NET 6. So we have these multiple release efforts that are always underway.
Yeah, I actually think you could make the argument that you save a lot of trees, because every time the runtime improves across millions of operations, trillions, gajillions of operations across billions of computers.
Dinosaurs and their fossil fuel. Yeah.
Well, very cool. I know you have some demo-ness prepared. What do you want to tackle first?
Yeah, so I thought would be fun to talk about source generation a little bit, since it's tooling, and it's also something that we've been investing in more and more, and we kind of started doing so in earnest in .NET 6, since it was sort of, Roslyn source generators came out a little bit before that, and we started taking advantage of it, dipping our toes in the water, and so we're more than doubling down on it with .NET 7. So people probably know, but just to provide some context, so Roslyn is the C# compiler implemented in C#. And one of the big things that it added years ago was the ability to hand off kind of the syntactic and semantic model for all the source code in your project to additional components, where you can basically augment the compiler. You get all the source code handed to you and its analysis, and then you can provide additional diagnostics and whatnot. And that's really, really cool. And we've started taking significant advantage of that since, many releases of .NET ago. We started shipping more and more .NET analyzers as part of the SDK. So we could recommend, this area of your code could be improved from a reliability perspective, or that area could be improved from a performance perspective, whatever. And every release we've seen more and more of these go in, and it's been really fun to see community contributors as well. A lot of the new analyzers end up being contributed by folks from the community, which is awesome.
So anyone watching this stream could actually be a part of this magic.
Absolutely.
Saving everyone time, millions of people, billions of machines.
In fact, some of the best reactions I get for when I, do various perf talks is when I, yeah, you made that faster in the runtime. Oh, but you can make my own code better by these analyzers. Like, oh, that's really cool. And so that gets a lot of positive feedback. But after analyzers came the ability, well, you're not just restricted to looking at the code that was already there, but you can basically take that code, look at it, and then add more. And so source generators basically provide a way for you to inject additional code into the same project. And one of the, this comes about in a variety of ways, but often it shows up as you tag something with an attribute, and then the source generator will come along and kind of provide an implementation based on that attribution. Or you provide a partial method, and the source generator will come along and fill in that partial method for you. And if you look at .NET 6, we shipped a handful of these in multiple forms. So for example, ASP.NET now implements its Razor, compilation, going from the Razor language basically to C# as the C# source generator. Windows Forms has a source generator that injects basically your whole startup routine, so that all the boilerplate you would normally see in your main and you have to have in your main, like is handled by the source generation off to the side. There's some in Maui and in Xamarin and everywhere else, but in the sort of runtime library space, we've also invested there. And so in .NET 6, we shipped a couple source generators. One of them for logging. So if you look at your logging methods, there's typically all this boilerplate you need to write. You have to first check whether your logging is enabled at a particular log level, and then to do all this serialization. And wouldn't it be nice if you could just kind of write the signature you want for your logging method and have that automatically filled in kind of with best practices? And so there's a source generator that does that. There's also a source generator for JSON serialization, where all of the work that would previously be done at runtime to do all the reflection over your code and generate kind of all the little stubs necessary to efficiently do the serialization, that can all be done at compile time, kind of right, in the IDE, in the C# compilation, in the build time compilation. And in fact, we can then take it a step further and kind of generate the most efficient serialization we possibly can, customized to your particular type, rather than kind of having a generic framework that we plug into for serializing any arbitrary type. So I can show that if you could bring up my screen.
Absolutely. We were just chatting in chat a little bit. We did say during the .NET 20th anniversary that .NET 7 Preview 1 would come out today. So that's a very exciting little tidbit for everyone. It doesn't look like it's posted yet. I was just going to put that in chat, but I'm going to be keeping my eyes on the .NET blog. Occasionally we find something and it's like costs us a few days. So, but it'll be, we were trying to do it this week. We were trying to do it with the 20th anniversary. So anyway, sorry, launch into.
No, that's fine. I think it's really fun that we have these moments where we say, oh, Preview 1 is released. At the same time, we have nightly builds of Preview 2 that have been out for a long time.
Yeah.
That's what
you could just go grab them now.
Yeah, exactly. So if anyone wants to follow along, just go grab one of those.
Get a nightly, yeah.
But yeah, so this is VS 2022. I've got a little console app here. I've got my little, POCO type person, first name, last name. And I could use an instance of this type with JSON serializer. And if I were to do, I could say like JSON serializer dot serialize with, a new instance of my person, first name. I can spell my own name. But when I do this, the JSON serializer is going to have to kind of reflect over this type at runtime to figure out all the things that it needs to serialize. Wouldn't it be nice if all that work could be done at compile time? And it can. So if I, add a little bit of boilerplate to my project, where basically I create this thing that derives from this JSON serializer context. We notice it's partial, and that's because the generator is going to fill in a whole bunch of details in this implementation. So I don't have to write any body here, even though this type actually has multiple abstract methods. So if I was deriving from this myself, I would have to override all those. But the generator is taking care of that for me. And I just tag it with whatever all the different types that I want to be serializable with this mechanism. I just tag it with this attribute, and then it goes and generates a lot of code for me. And we can actually see that code. If I say go to definition, we can see there's a whole bunch of source files that it's creating here. This is the one that's most relevant. We can see that it's spitting out information based on doing that effectively reflection at compile time. So using that source model that was provided by Roslyn to say, oh, there's a property called first name, and I know what type it is. And it's gathering all that data such that it can be supplied to the serializer. So the serializer doesn't have to do any reflection at runtime, which is nice for performance in multiple ways. It's nice from a startup perspective because we get to avoid all of that reflection costs. It's nice from a size perspective because then if you want to link your application, trim your application, you can trim out all of that reflection goo that would otherwise need to be used, because all the logic that's necessary to describe the type is right here. And it's also nice from a throughput perspective because we can spend more time at compile time doing analysis and generating the best code in the source generator than we can at runtime, because we have a limited budget for what we can do at runtime. And to that end, in addition to generating all of this kind of descriptive stuff, it can also spit out kind of the sort of the optimal serialization routine that I would want if I was writing this by hand. So we can see, if I was writing the serialization by hand, I'm going to take writer, some kind of writer object, and I'm going to tell it I'm starting an object, I'm writing the first name, I'm writing the last name, and then I'm done. And you can see this updated in sort of real time. If I were to come in here and add in, say, public int age, you can see now it's augmented the source with writing out a number for that additional property that I've added in. So in real time, it's able to generate this code that will be spit out into my assembly. And when I go to serialize a person class, it can then use this optimized routine rather than having to fall back to the consulting each of the properties and figuring out what to write for each. And so it can result in significant 2, 3, 4, 5, whatever X throughput improvements on your serialization, on top of the wins around trimming and linking and so on. So this stuff is all really, really cool. As long as we're talking about tooling improvements, it's also worth calling out some really neat things that are coming in Visual Studio 2022, whatever the next dot release is, 17.2 or whatever.
We'll be in 17.2 preview really soon. I think we might have released on the 15th. I'll double check though. So
one of the cool things that's been done is we've added this new attribute to .NET called string syntax attribute. And like many attributes, we ship it in the runtime in the core libraries, but the IDE and Roslyn don't really care where it's defined. So someone, if they're not using .NET 7, they could still kind of copy and paste the source as internal into their own library and take advantage of it. And what this does is it allows someone to say, I have a string, and this string contains some other language. So, if you're embedding some kind of domain-specific language like JSON into your code, you can basically communicate that to, say, the IDE. So the IDE knows, oh, that string is JSON. I can do some interesting things with that. So you can see here, if I do JSON serializer dot deserialize, let's say I want to deserialize a person. If I look at the definition of this method, you can see this property is tagged as string syntax JSON. So we're basically telling the IDE that this is JSON. And so it can do with that what it wants. So if I were to, start typing like first name equal, Stephen or something like that, we can see I'm getting interesting syntax colorization where my property is showing up, my property name is showing up in one color and my property value is showing up in another color because it's doing all of that. It knows that this is JSON, and so it can parse it and colorize it as JSON. And if I were to make a mistake, you see not only does the syntax colorization go away, but now I start getting errors specific to JSON. So it's hard to tell because it's really small font, but it's giving me a JSON specific error here saying that this isn't valid and trying to give me some additional details about what I could do to fix it. And so we've gone through and attributed everything in the framework, basically in the core libraries that accept JSON with that string syntax JSON attribute. And we're able to, and the IDE and Roslyn have been able to do interesting things with it. This shows up as well in other places, for example, not just with JSON, but we've also, if you were to look at in previous releases, if you had some sort of date time and you were to do dt.toString, you see one of the things that pops up, and again, sorry, my font is really small, but this is popping up an IntelliSense menu that's telling me about the format specifiers that work with datetime. These are really hard to remember. There's a lot of them. And this is helping me to figure out what I want to type. Now, previously, this had been hard coded for basically datetime.toString. But now we've gone through and attributed a whole bunch of members in the framework to with that same syntax attribute. So for example, if I were to do XML convert toString datetime, now we see I get that same menu here because this toString overload that accepts a datetime has been attributed with string syntax datetime format. And so now anywhere datetime format is applied like that, the IDE can go and provide that same IntelliSense. And so we're adding, more and more of these sort of languages. It's extensible, so anyone can define whatever the language they want. But as we have more of these domain-specific languages in APIs in the core libraries, we'll add more of these tokens, and we can teach the IDE and Roslyn about them. Then they can do interesting things.
Oh my gosh!
So it's really nice, sort of a really nice experience. And that actually
love for this. That is so cool. I am so excited we're integrating that with the framework. Wow, wow, wow. Yeah, other people are too.
Oh, great. Yeah, it's really great for tooling scenarios. And this actually carries over to regular expressions as well. So I talked about source generation. One of the things that we've invested in for .NET 7 is source generation for regular expressions. And I'll finish my segue in a moment, but Regex has long had, not long, but for several releases now, Regex has had colorization for the Regex constructor. So we can see if I had, some regular expression here, we can see I'm getting syntax colorization based on the IDE and Roslyn knowing that Regex's constructor takes a regular expression. Well, now in .NET 7, this is attributed with string syntax regex. And so anywhere else where we accept regex as a pattern, it has also been attributed as string syntax regex. And again, it's not just colorization, but if I were to make a mistake, like missing a closing brace, we can see I'm getting this regex specific error saying regex not enough close parentheses. And because this is now tied to that string syntax attribute, this carries over to our source generation support that we have in .NET 7. So let me segue over to that.
Can I ask a quick question?
Yeah, please.
So love this. Stop Morton. Hi. Can they declare their own string syntax attributes so you can get support pre.NET 7?
Yeah, so like many attributes in .NET, Roslyn isn't looking for them specifically within a particular assembly. It's just looking for it by name. So if you were to literally copy and paste the string syntax attribute in the right namespace into your own project, just make it internal, please. You can use it as well. And so then you can, in pre.NET 7. So you could tag it with any of the tokens that it currently understands, JSON, datetime format, or regex, and the ID will line up with it. You could tag it with other languages as well. The ID just won't know about them, but your own tooling might. So for example, you could tag, as this is my SQL string. And then you could have your own Roslyn analyzer that looked for anything tagged to SQL and validated that it was well-formatted SQL or something like that.
Wow.
Yeah.
We are happy to hear this.
Doing that now.
lots of chat. I love seeing the chat. It's so cool. You were transitioning to something else.
Yes, I was going to talk about regex. I was going to say, because in .NET 7 we have this new regex generator, which has this new regex generator attribute, and again, because this itself uses string syntax regex, all of that goodness that applied to the regex constructor now automatically goes here as well, and every other API we have that accepts regexes. So I get the same colorization here that I got elsewhere. I get the same errors here that I got elsewhere, because Roslyn is applying that same analysis and colorization to anything that has that attribute on it. But that's not the main benefit of this regex generator. The main benefit is we're now doing source generation for regular expressions. So folks may not know how regex in .NET works, but basically, if you just say new regex, whatever your expression is, ABC, DEF, whatever, under the covers, this constructor is going to analyze that string, parse it into a regular expression, effectively, I'm going to use the word compile, but lower it into, transform it into an in-memory representation that it can then interpret, such that when you then call, say, isMatch ABC, it's able to relatively efficiently use that in-memory description of the regular expression to process this match. Now, there are a few problems there. One is, every time I create one of these new regexes, it has to do all that analysis, parsing. We apply some optimization, so it has to do all that stuff and figure out what that in-memory representation is, just to get to the point where it can start doing matches. And that would be something that we'd like to front load. We'd really like to be able to do that all ahead of time. On top of that, it has long been the case that the way you got the best performance out of regex was by specifying regex options.compiled. And what that did was, after it did all that other stuff, after it parsed the expression and figured out kind of this representation, it would then take that representation and use reflection emit to generate IL customized to that exact expression. So it would generate this large body of IL that would then be JITted, and that whole process could take a long time, relatively. We're talking milliseconds, but in computer world, that's a very long time. And then your matches would be very fast, but that process could take a long time. And we really wanted to make it such that we could do all of that at compile time when you build your app, rather than at runtime. Now, .NET Framework did have a mechanism for this. There was this little known or little used API called regex.compile-to-assembly, which would basically do that same reflection emit and then save it out to a separate DLL. But the ergonomics of this were difficult, and it made it so that very few people actually did it. But source generators allow us to do it right into your same assembly and in a language that you can read. So, if I go back to my example here, so I've got an empty string right now. And so my regex generator, it's not doing a whole lot of interesting stuff at the moment. I can tell you what it's doing though. Basically, I've got this method, myRegex, that's partial. And the generator has generated basically a static cache for an instance of a regular expression to be returned from this method. So every time I call this method, it's just going to return the value from the field. So I don't have to like cache this on my own. It's doing all that caching. The thing that it caches is a custom regular expression implementation that derives from regex. We can see it's deriving from regex and overrides using the same extensibility model that compile to assembly mechanism had used. It's basically, instead of spitting out IL, it's spitting out C#. So in .NET 6 and prior, this is going to change in .NET 7. I'm not using a build yet that reflects it. There were two methods that basically got overridden. One of them was called find first char, which is basically what regex would use to, as fast as possible, skip as far into the input as it possibly could, looking for the first place that there could possibly be a match. So if I was looking for ABC, it would skip over, everything that wasn't an A, looking for the first A. And then once it found a possible place that could match, then it calls this go routine, which actually does the full matching logic. Now, because I'm doing an empty match here, we can see there's not a whole lot of stuff that's interesting. I am getting a nice English description that says what's happening. I'm matching an empty string. But all find first char is doing is saying, well, because an empty string matches everything, as long as I'm not yet at the end, yeah, this would match. And the match routine says, yeah, this is a match, like capture, provide a capture for the whole thing, and we're done. But as soon as I start typing here, we can see I get a much more interesting implementation. So now find first char, excuse me. Sorry, one second.
This is just crazy to me watching, because as you were editing here, it has actually generating that, you had it generating the code here, right? So we're seeing the logic behind the scenes.
You're seeing the logic
or in C#.
Exactly. So it's generating. I wanted to search for ABC, so it's generating an index of for ABC. And now any optimizations that are imbued into index of, and there are some pretty nice ones coming in .NET 7, automatically accrue here for free. But then we can see, because I know that because it knows that if this returns true, then it's a full match. Our Go also doesn't need to do anything interesting, because it just needs to know, well, ABC was 3 characters, so I can just do a capture, because if I got to the Go routine, find first char has already performed a full match, and so I'm good to go. But now let's change it up. Let's change it to ABC or DEF. So now we see something interesting happening. So we can see find first char has changed. No longer is it doing index of ABC, because that would be wrong, right? It needs to look for the first ABC or DEF. So what is it doing? Well, it's doing an index of any, looking for a character that appears on the left side of the alternation and a character appears on the right side. So it could have done A or D, could have done B or E. It's chosen to do C or F and then back off by 2. And it's chosen to do that because, based on kind of predetermined frequency analysis, it believes that A's and E's are a whole lot more likely in the kind of corpuses that regexes are used to process than C or F. So it has a much higher chance of having not having false positives by searching for C or F. So it does that, and then to make sure it can stay in this loop as quickly as possible, it also does a quick check to see if the first 2 characters are possibly what they should be. And once it's done that and it returns true, now our Go routine actually does the real match. So we can see it's saying, well, if there's nothing here, then there's no match. It's doing a switch on the first character because it sees that the 2 branches don't overlap. So it knows that, if this matches, then this can't possibly match. And if this matches, this can't. So it generates a switch looking for an A or a D. And then we can see it's also spitting out, as efficient as it possibly can, a match for the string BC. So it's doing a single read of an integer, which is 4 bytes or 2 characters, to match the remaining BC. And over here, it's doing the same with E and F. And you can write arbitrarily complex expressions, and we throw pretty much any optimizations we can think of at this thing. So let's say I did A star B. So a couple interesting things to note. This is a greedy loop, which means that it's going to consume as many A's as it possibly can, and then only then will it try and match a B. And normally in backtracking, what happens is you match as much as possible, and then you start backing off. But because based on this expression, it knows that it won't have to do any back off because there's nothing that this loop could have consumed that would also match B. So under the covers, it's automatically converted that loop from being greedy into an atomic loop. And then you can see it's generating that code to just as many times as possible find as many A's as it can. And only once it's found those does it then try and match a B. And you can see it tries to do relatively smart things. So if I were to do A plus, A plus, A plus, A star, even though I've got all these loops here, it's still only saying I'm going to generate one loop and I'm going to match that A at least twice atomically. So it's just it's not generating a whole bunch of loops. It's generating one loop, recognizing that all of this collapses down to just a minimum of 2 A's, and then as many A's as were desired. And there are a whole bunch of interesting things that it can then do on top of that. For example, if I did, let's say I did ABC, and I did a loop, and then I did a /W. Well, /W, C does overlap with /W. So it can't make this loop atomic. And we can see that it's going to match C greedily any number of times. But as part of generating this loop and as part of generating the backoff logic somewhere here, that's not what I wanted to do. Well, doesn't matter. It's not doing what I thought it was going to do, but that's close enough. It's sort of generating all of that backtracking goo because now it sees that it is, it is a greedy loop and it's handling being able to back up. You can see it's using go-tos because it has to, because it needs to be able to jump backwards to previous things. So we try and make the code as pretty as we possibly can, but we still end up using some things that may not look ideal because we're having to generate some pretty complicated logic that's doing lots and lots and lots of jumping around. But it's really fun to just sit here and play with it and see all the kinds of things that it does. For example, if I made this regex options dot ignore case, now we can see that it's actually effectively lowered this into a search for the set of either capital A lowercase a, capital B lowercase c, etc. And when it's actually doing the matching, you can see it's doing it as efficiently as it can. Rather than checking if equals A or equals capital A, it's doing kind of that ASCII trick of kind of using a bitwise or based on knowledge of the ASCII table to know that this either the capital A will lowercase to lowercase a with this bitwise logic.
Oh my goodness, that is ridiculously clever. Wait, so Shreyas told me he's telling me how to host now. I need to interrupt you, let you take a drink of water, and ask you a couple questions.
Okay.
I appreciate the nudge. I think that's good. I do like this breakdown. Just so in other words, it generates the library based on the code that you use. And I think like even more than that, it makes optimizations based on only the code that you're using.
Yeah.
If I can add, yeah.
And we have more of a budget to do it at build time. We want builds to be fast, but we want startup to be faster, right? So we can take a little bit more time at build to do more analysis, do more optimization than we could even do in regex options.compiled, because we don't want to take forever doing regex options compiled, but we could take an extra second at build time if we had to make this regex the fastest we possibly could.
Excellent. I felt like I saw another question. Oh, I liked this one. Yes. So can this generate something like cyclomatic complexity so you can estimate how efficient your own regex is? Because it's very possible. But yeah, sorry. Some of this might just be self-indicative. If it's generating something gnarly and terrible, you might might be able to simplify it. Yeah.
We don't spit out any kind of cyclomatic complexity or any kind of numerical description of its complexity. But as I mentioned, we do spit out an English description of what's happening. So if I had a set of loops that were overlapping here, so that it can't make these atomic. If I go and look at the description, I'm going to see like I've got a whole bunch of greedy loops happening. It can only make the last one atomic. And anytime you see loops, that's indicative of something that if I have loops one after another, that's sort of increasing the polynomial complexity of my regex in sort of this backtracking engine, because backtracking engines basically process a regular expression the way that you kind of would think they would be processed, where you kind of explore one path and then you back up and you explore the next and you back up. And so if you have a whole lot of loops, you can imagine every time you hit one of those loops, you try something and then you back up, you try something, you back up. And if every time you do that, you're doing an entire additional loop, you kind of have to multiply them together. What's even worse, if you had all of that within a loop. So now in the description, you can see, I've got this loop happening around a whole bunch of other loops. So because you can kind of see it in English and read what it's doing, you can much more easily see places where you might be able to improve your regular expression beyond what we were able to sort of automatically determine. And a good example of that would be, it's pretty common for people to, let's say I was trying to match brackets or something. So I might write a loop like this. This is, as you can see, it's saying I'm matching, looking for an opening bracket, angle bracket, and then I'm going to match a character other than /n any number of times. That's because dot means /n by default. It's basically a new line. And then I'm going to match this. But a closing bracket is not /n. And so this loop could possibly match something that is this closing bracket. And that's why you see here, it doesn't say lazily and atomically, it just says lazily. And if I look at the matching implementation, there's all this goo to handle the possible backtracking. When what I really wanted to say was, rather than this dot, I really just wanted to match anything other than a closing bracket. Now, that's not something that the implementation could deduce for you because it's semantically different. So we can't make that change automatically. But the implementation can do that for. But when you tell it that's what you want to do, then the implementation can take advantage of that to kind of do the optimization, relevant optimizations for you. And so those are the kinds of things that reading this information can show you.
Yeah. Really quick one question. So what build of Visual Studio are you using? Because it feels like you're not reloading VS every time you make these changes. They're kind of just appearing in your source generated code. Is there any special version you're using?
No, this is how source generators have worked for a long time. This is just, I've just loaded up the, I went to right-clicked and went go to definition, and it's just, as I'm typing, the source generator is overwriting this sort of file, and so I'm just looking at that file. So I'm using a relatively recent build of Visual Studio, a Preview 2 build of 17.2, but this would work with the vanilla VS 2022 that was released back in November or whatever. Yeah.
Super cool. I might have misspoke. Someone was asking to kind of catch up with what this demo is about. And I mentioned these are improvements in .NET 6 and 7. Is this specifically coming in a later .NET 6 release? Is it already out?
This is all, the generator is all .NET 7.
Oh, it's all .NET 7. Okay. Yeah. Thank you for the correction.
All right, yeah. The JSON stuff was .NET 6. And the generator, I should have said that. Or if I didn't say it, I should have said it. This regex generator.
That's why we have chat. They keep us on track. Thank you. Oh.
The other, another interesting thing that's new, I'm not going to dive into it a whole lot. We're still working on it. It still, needs some improvements. But the other thing that we've added for performance in .NET 7 is an entirely new engine behind the regex. So I talked about backtracking a few times, and we've added this new non-backtracking option, where if you say non-backtracking, basically we switch the entire implementation over to one that will never backtrack. And that employs an entirely different mode of processing that is able to guarantee linear processing in the length of the input. So you no longer are worrying about, lots and lots of loops, one after the other in your input, because no matter how many you have, you're still going to be linear in the length of the input. Now, there are some trade-offs that are made with this. There are some features that don't work, things like back references, atomic loops, conditional expressions, various things that don't work, but those are all sort of also niche. This basically, in the best case, it's usually a little bit like for best case input where your expression is going to match and it's going to match really fast. This will often do a little bit worse than the other engines, but for the worst case, you can write expressions and inputs that in the backtracking engines have exponential processing time in the length of the input, and this will be linear. And so it's a really good choice. It's a really good option if you're going to be accepting, in particular, untrusted patterns from somewhere, places where you didn't write the pattern yourself, and you want to basically have some guarantees about how long the execution is going to take. This option is going to be really valuable for that. So that's also something to check out. It is in preview 1, which I believe you said comes out today, Kendra, but I would probably wait to preview 2 to check it out because there were a few features that were missing that are coming in preview 2.
Nice.
So these two, so going back for what we just saw, so for some of the people that are new, these are both in .NET 7.1. The regex source generator makes it possible to actually more easily compile your regex in advance at build time. And then the magic we saw here with the source generators was using VS features. You could use those source generators today to watch the file getting regenerated. But that was an example of how the engine's generating code, and the new attribute lets you easily do that at build time. And then there's also a new option here with the non-backtracking option there to, I guess Sans using a few features that can now guarantee the processing time is more than that. Linear, right. Not a bunch of looping stuff. So it's a big performance optimization, right?
Yeah, in particular, it's an optimization for worst case. So you hear every once in a while about these accidents where a bad expression with a bad input took out a server. Like Stack Overflow had a big incident with this a few years back. And this is very squarely focused at defeating those sorts of problems. It's the same approach that Rust uses in general in its regex, and RE2 uses in its regex. Go with RE2 uses for regex. And those, very squarely focused on being able to make these linear guarantees.
Very cool.
I don't even, how much time do we have?
As much, we try to probably keep it under an hour. But if you have a lot of good content and you're having fun, we can continue to have fun.
I'm having fun. I'm happy to go until my voice literally gives out.
Oh no, yeah.
Another example of source generation, which I think is pretty cool. Where am I looking? Where am I going?
Do you want to break for some questions a little bit? Chat is super active.
If you got questions, I'd love them.
Yeah, I'm trying to keep up with them. So what is the process for determining per allocation memory optimization that the team follows?
The process, meaning like the people process, like how we go about, well, I'll assume that's what you mean. So there's a few things. The first is sort of how do we ensure that things don't get worse? And we have a whole suite of micro and macro benchmarks that are run very frequently on a whole bunch of operating systems, on a whole bunch of architectures. And we have regression analysis in place to kind of, with heuristics, flag places and ranges of commits where something that we care about may have regressed. And similarly, where something that we care about may have improved. So we're able to tie those back to the changes that made them usually within, some range of commits. And then we can go and figure out, well, why did that regress? The flip side is focusing on things that we actually want. And I should also say, anytime PRs are submitted, One of the things as reviewers for PRs is our job is to sort of, as we're reviewing the PRs from other folks on the .NET team or other folks at Microsoft or other folks from the community, one of the things that we have a keen eye for is places where we suspect the change might possibly negatively impact performance. And that might be okay in certain situations. I mean, we readily take changes that we know will be a negative impact on perf because we're trading it off for something else. Like we're getting some important feature, some important security guarantee, and we expect we're going to take a 5% hit on something. And that's just sort of the cost of doing business. Now, oftentimes we'll also try and offset it in some way. We'll then spend more time trying to get that 5% back by doing optimizations we might not have other worked hard to do. But those are the, like if you submit a PR to .NET Runtime, you'll probably see one of us say, hey, have you tried running the following benchmarks, or have you looked at the performance of blah? Or we might even go off and try it with your PR, your commit, and see what it means for perf. The goal being, we don't want to leave it up to our regression analysis, because by then, it might be a few days or a week or something later that we have enough statistical data to say, oh yeah, there was actually a regression here. Unless sometimes it's such a big performance hit that we can tell immediately. But usually, when you're dealing with 2, 3, 4% regressions, you need enough data over time to show that it's not just sort of the daily noise of the environment. Then there's sort of the focus on, well, we're going to actively make improvements. And this is a little bit more of a varied bag. Sometimes it's self-driven, where we have seen places where we know from looking at our own services, running in Azure, or customers have shared profile data, or whatever it may be. We know that certain APIs are being used extensively on hotpads, so we'll focus attention on those APIs and try and make them faster. Sometimes we have sort of a new priority that we're thinking about, and we want to make sure things play well together. So, for example, we're really focused on making sure that ARM64 is great. And so one of the things that we've done in this release is add, we had previously added hardware intrinsic APIs, thousands of them literally, to allow you to target specific instructions on various hardware. But because lots of developers don't have ARM64 hardware, if they were going to use these intrinsics, they were probably only using the ones for Intel, x86, x64, and then ARM64 would lose out because these optimizations that made these great improvements over here didn't accrue over here. So one of the things we've done in this release is add a new set of cross-platform APIs, Vector 128, Vector 256, and a whole bunch of APIs on those that work great regardless of the architecture that you're targeting. And the JIT under the covers does the right code generation, essentially as if you would use those intrinsics directly. So that's a case where ARM64 was sort of a strategic directive for us, and we did the performance improvements necessary and the APIs necessary to get there. And then I'd say there's a large category that is opportunistic, where we see someone report a problem. Someone puts out a blog post that says XYZ is slower than it was previously, or it's slower than Java or whatever, and that it makes us want to
get after it, yeah.
Solve it. And so we're sort of opportunistic at that. If you've read the blog post that I put out on performance stuff, a lot of the improvements actually come from the community. I think something like 15 or 20% of the PRs we had around perf in .NET 6 were actually community submitted. And so those are things where they weren't optimizations that we were planning to make, but they were something that was important to someone else, and they were able to go and make the change, and we were happy to kind of work with them to get it in. And then our goal is to just make sure that nothing else is being harmed in that process. I don't know if that fully answered the question, but that's the general process that we follow.
I think it did, because we weren't sure. You kind of went over the people difference and how you step through PRs and accept changes and stuff. Did you mention like perf regression tests at all?
Yes.
Okay. I felt like that was a big one. Okay. Good. Sorry, I was trying to keep up with chats. Tanner wants to know what perf features we're most looking forward to in .NET 7.
Well,
Hi,
there's
Tanner.
this great developer on our team that implemented these cross-platform vectorization types, and I think those are my favorite. Tanner.
Tanner. Awesome. Cool. And then just generally, what about just general features in .NET 7 are you excited about?
That's a good question.
Being a bit of an authority on the matter.
I mean, to some extent, we're still figuring out what that looks like. We've got a whole bunch of plans for things we would like to do, and it'll be a question of what we actually get done. I have a few pet projects that I would like to see happen, or rather, they're not really projects, but sort of long-standing warts that I would like to see addressed. A lot of what I think we'll see in .NET 7 will be filling gaps. For example, we really want .NET to be a great story on Linux. So what are the things, having grown up in the Windows ecosystem, what are the things that .NET lacks that are really prevalent on non-Windows, on Linux, for example, on Mac? And for example, one of the things you see is tar as a packaging format combined with like gzip. So you see pretty much everything you download for Linux is .tar.gz. Well, .NET lacks a built-in tar story. So that's something that I'm hoping we'll see show up in .NET 7. And it's a relatively small thing, but I think it's very meaningful when it comes to .NET playing nicely in that ecosystem.
It feels very obvious. Yeah. I'm kind of like, oh shoot, yeah. Sometimes we discover these things and it's like it just feels like an obvious thing that we need to do to fit well with where the platforms we're trying to play nicely with.
And then there are other bigger features that we've been working on for a while. For example, in .NET 6, we shipped as preview HTTP 3 support. Like that's a really big piece of work. Under the covers, it's using Quick, the Quick protocol, but we didn't expose that publicly. So for excuse me, for .NET 7, we'll be exposing. The plan is to have HTTP 3 be fully supported, Quick as public APIs fully supported, and I'm looking forward to things like that as well.
Oh, that sounds so cool. So I got a question for Jordan. What have you most appreciated in the last 7 years versus early .NET? So I think this is specifically referring to kind of .NET Core and when we made a major transition in the ecosystem to go cross-platform. I know you're a big VS for Mac guy.
Yeah, I was going to say, if we talk .NET 7, I honestly have not had a chance to keep up as much there lately as being heads down on some of the stuff we're doing in Visual Studio for Mac. But my early days of .NET, it's a little more relevant. Based on this discussion today, it's got me looking back. There was a lot of grunt work in the early days of .NET we did on the application I worked on, where there was reliance on a whole lot of early code generation tech, where I would generate I like domain-driven design. I would generate a whole bunch of the back end off of a database, and the amount of hoops you would go through, the amount of time I spent on that stuff, where I flash forward to today and things like source generators probably would have eliminated months of work that I did to kind of save myself another months of work to by hand code up the domain model. And so those sorts of improvements, I'm very big on the technology, getting the grunt work, some of that extra stuff out of the way for me, so I can really focus on my problem to solve. I don't have to think, is this regex implementation the most specific, most performant thing? Worry as much on those nuances like I used to have to do. And now I can kind of trust a little bit more, like where the tooling's going, that some of that stuff's even further. Like, I don't have to worry about those pieces yet. I can focus on the thing that's about the business and getting me to my feature.
I love it. So kind of on that note, what is ETA of .NET 7? So we're trying to release major versions of .NET every year, once a year in November with .NET Conf, and the excitement there. So we're looking for this November is the official GA version of .NET 7, and then preview 1. I was pretty sure it's coming out today, but you can definitely get the nightly builds. We did announce it was coming out this Thursday, but I'm like refreshing the page and I don't see it yet. So we'll see. Kind of adds a bit of excitement. Kind of a will they won't these situation. We'll see. I think that's all. I was trying to kind of give Jordan and I some talking points, give Stephen a rest. People are very, very thankful for you sacrificing your voice, heart, and soul to share the updates. Big .NET thumbs up.
That was a really fun demo watching that. Oh man, yeah, a nice way to demonstrate the feature, but also kind of seeing the tooling again.
Let me do. I'm going to give the rest of my voice just to show one more, because I think it's really cool, and I won't do a very long one because I think I've got like 3 sentences left.
Jeremy just posted the .NET 7 Preview 1 download on the blog. I'll share that. Sorry, and then we'll switch over. I'll share your screen again, Stephen.
I wanted to show one more source generator we're using in .NET 7. So I don't know how many people know, but when you write, lots of libraries in particular or applications can't find all the functionality they need in the core libraries or libraries they get from NuGet, and they need to, p-invoke to something in the operating system, whether that OSP Windows or Linux or Mac OS or whatever. And historically, you would use the DLL import attribute to do that. But when you did, depending on what you've asked it to do, the runtime might have had to do a whole lot of work as part of every function call. It might not have been able to just call the underlying OS API. It might have had to do some marshalling. It might have had to do some sort of pre and post logic. And to do that, it would have to generate at runtime, effectively using reflection emit, or the runtime's equivalent of it, a stub, basically a function that would do all that stuff for you. And with this new source generator in .NET 7, we're again able to do all of that at compile time. And so I can see an example of that here. I've written, again, a partial function the generator is going to fill in. I've used generate a DLL import rather than DLL import. And we can see down here, it's generating the DLL import for me. Now, it's interesting. Right now, this function is simple enough that there's no additional work that this has to do. So it's just generating a DLL import that is directly what I wrote. However, the moment I change this to something else like bool, which isn't directly marshalable, now we see the generator has actually spit out a version of this function that calls a different p-invoke, one that actually returns int. And here, after it calls it, it's doing the marshalling to say, was that integer 0 or not? And it's doing that translation. Or if I made this say accept a safe handle, now it's doing all the work that would have otherwise been generated at runtime to do the interaction with that safe handle to basically ensure that if the handle was disposed while it was in use, it wouldn't cause problems. Or if I were to say set last error equals true, we can see it's then doing all the work to preserve the error that was occurring. So you can actually see all the magic that the runtime would have otherwise been doing for you as a great learning tool, just like with Regex. But also getting all the startup advantages of not having to do all this code generation at startup time, while also being able to see in clear C# exactly what marshalling was happening for you, so you can kind of really debug it. And that's a point that I didn't land well early with Regex. With any of these source generators, I can set a breakpoint. I can hit F5. This is just code in my application. I can step into it. I can hit it. All this can show up in my PDBs. It is fully a part of my app, and it's just pretty powerful. So if you look at the .NET Runtime repo in .NET 7, we've converted almost all of our existing DLL imports over to this new strategy. Pretty cool stuff. That was the last thing I wanted to show.
Amazing. Wow, thank you so much for coming on. This was an exciting stream. .NET 7 Preview 1 was released. We got to see some of the amazing source generator improvements in Regex that set the chat on fire. It was amazing. Really cool. Well, I hope you kind of recover, go get some tea. Thank you so much for going the extra mile today.
Oh, thanks for having me.
Yeah.
Sorry about the voice.
Oh, gosh. I think it's worth it. Absolutely worth it. So I guess we're really excited to see, I guess, hopefully the performance blog post, because I think many people would be happy to read 190 pages or of more of these kind of goodies and how their runtime's improving little by little with the community and all of that. Cool.
Awesome. Thank you both.
Yeah. Thanks for coming on. All right. Well, I'll wrap it up. Everybody go download .NET 7 Preview 1 if you aren't already on the nightly builds. If you want to be on the nightly builds, check out the .NET Runtime repo. I put the link in the chat. And I'll catch you all later.
Take care, everyone.
Bye, everyone.